Okay, this is assignment 2. We've got a dots and box game. So a quick demonstration here is we've got our game. It asks the player to enter a board size. So I'm just going to do a 2x2, and then the maximum amount of plies or depth that the AI can check. For this, real quick, I'll just do 2 as well. So I make a move, row and column, the AI makes their move. I make another move, the AI makes a move, and so on and so forth until the game is finished. If I make an invalid move, it tells me, and it asks me to make the move again. And so on and so forth. Okay, so the way this works is when it's the AI's turn, we call the min-max algorithm, and what that's going to do is it's going to check the best path. I guess at the moment I was using the best path that was pruned, but just real quick I'll swap this back, and you can see that it's pretty much the same, at least at this size and depth. Alright, and so what this does is it creates this new path, and the path is going to be made of a list of game states, and then it calls this function here, which is going to be recursive. And so every time this is called, what it's going to do is create this new path. It's going to make sure that we're making a legal move, and then it's going to clone the path that we're on. It's going to try to make a new move, and then if we are in the player's case, it's going to try to return the worst best path possible for the player, because it assumes that the player is going to do, you know, the best move the player can, but it wants to give it the worst one of those best moves it can. And then for the AI, it wants to find the path that's going to return the best points for it. Alright, it compares those, and then returns the appropriate one, and calls us again and again until it finds the best path that it can at the depth that we gave it. Alright, so then the way it makes a move is, first off, it checks to see if a move is valid. So it goes over here and make sure that we're within our bounds, and make sure that the move that we're in is going to be a space. That way we're not looking at a dot, a value, or a space that's already been used. Alright, and so then since I use this function both for the actual movement as well as the paths that the AI calculates while trying to find a movement, we just go ahead and clone a new state here, and then it checks to see if there was a score made. It does this by moving over the row and also moving over the column, so that way it gets the value of the box, and then it checks all 4 sides of the box. So we can see that it gets score, make sure that we're within our bounds, and then if at any time we don't have the correct line surrounding it, it'll just return 0. Otherwise, it'll return the value at the row and column that we're in. Like I said, since we moved that over, it's going to be the value of that box. And since points can only be scored when a box is completed, it shouldn't get, that score should never get called anytime that you're not completing that box. Alright, so then if it was the player's turn, or if the AI was calculating for the player's turn, we add that score to the player score. Otherwise, we add it to the AI score. And then up here we also have something called player advantage, and what this is going to be is the player score minus the AI score. And this is what it uses to evaluate whether or not that move is going to be a minimum or maximum. Okay, so once we have found our best path, that goes back up into the thing that called it. We score it, and we do that in our original game state and return, and then it becomes the player's turn again. Alright, so if I wanted to step through the moves that the AI makes, I can do that here. We're just going to make this a smaller board. Okay, so we can see them move there, 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 but then they go back up and they evaluate the next branch, goes back up again, evaluates those leaves, back up, and so on until it's gone through all of the possible choices and made its best move. So this is going to be different from the prune path because the prune path is going to throw away any move that isn't better than the minimum or maximum that it's already found. So basically what it does here is if it's the player's turn and the advantage isn't greater than or equal to the cutoff, then what it's going to do is return the path that we already found. Otherwise, if it's the AI's turn, it's going to calculate that but the other way, so if the player advantage is less than or equal to, then we'll return that. And this is really the main difference here, but it quickens things up a lot. So if we step through that same example, we see it go down that path, and it looks a lot similar, but then we're going to see it skipped one here. So it doesn't go back to this branch to evaluate. It realized that the other move it could have done in this branch, where it starts with this on the bottom, isn't as good for it, so it moved on to the third branch. And it evaluated that. So a lot less leaves were evaluated this time through before it decided what the best move was going to be for it. So that is the bulk of it here. Another way that I like to demonstrate the differences here is I like to have the AI play against itself. So let me do 5 with a depth of 4, maybe we can get a good distinction here. Alright, so our AI player, scoring player, is taking their turn, and it's taking some time, but then our prune one took their turn and it was almost immediate. So now we're back into the AI, but then the pruned took their turn very quick again. So you can see it takes this long time for the regular mini-max to make a decision, whereas the pruned mini-max makes it very fast. As you probably saw, the numbers are all randomized each time, the values for the boxes. That was a close one. One good demonstration of it just kind of doing the best it can is having them both use the pruning. So I can make this bigger, I can make this deeper, and it'll still just run. As mentioned in class and was expected, at 5 deep, I was unable to beat this algorithm. Honestly, I might have been unable to beat it even shallower than that, but it's very good. Alright, and there we go.